Well, we are going to start 12.5 Day 2 notes. So today we're going to learn a couple properties for square roots. And the first one is the addition and subtraction property of radicals. So in words, to add or subtract radicals, the index and the radicand must be the same. Then we just add the coefficients. So this is actually a lot like combining like terms. If I have 2x and 3x, those are like terms because they both have an x. I just add 3 plus 2, and that gives me 5x. But we know that 2x and 3x squared cannot be combined because those are not like terms. Very similar with radicals. If I have the square root of 5 and the square root of 3, those are not like terms and cannot be combined. But if I have the square root of 5 and the square root of 5, then I can use this property. Okay? So here it is algebraically. If I've got a root b plus or minus c root b, then what we do is just take the coefficients, the a and the c, and we add them if it's a plus sign or subtract them if it's a minus sign. And we just leave the root alone. The root is kind of like that x. So let's look at an example. 3 root 5 plus 7 root 5. Well, we see the root 5 and the root 5 are the same, and they're both square roots. We know that because there's no number, and when there's no number, we know that's a square root. So now what we do is take these coefficients. We have a 3, and we're going to add it to the 7. So this equals 3 plus 7 root 5. We just add up the coefficients, and of course that's going to give us 3 plus 7 is 10 root 5. Well, let's look at this one. 2 root 10 minus root 10. We have the same root, the same radicand, square root of 10, square root of 10. In front of this one, we know it's a 1. So we're going to take 2 minus 1, root 10. That leaves us with 1 root 10, or just root 10. Okay? So let's put this property to use. First example, the square root of 8 plus 3 root 2. We are actually going to have to use our simplifying skills that you learned in 12.5 Day 1 for this. So we know the square root of 8 can actually be simplified. I'm going to use method 1 that you learned, and that is breaking it into a perfect square. So I know that 8 can be broken into the square root of 4 times root 2. 4 is the biggest perfect square that goes into 8. Well, we know that the square root of 4 is 2. So 8, the square root of 8, went to square root of 4 times root 2. Root 4 is 2, so it becomes root 2, 2 root 2. We're going to bring down that plus 3 root 2 because there was no simplifying that could be done there. Now this looks like this. We have root 2 and root 2, so we just take those like terms. 2 plus 3 gives me 5, and combine them. Next example, we have the square root 2 plus 3 cube root 2 plus 4. Now what's important about this is that the index also has to be the same. Well, what's the index? Remember, the index is the little number. So we know this is the square root of 2 and this is the cube root of 2. So these are actually not the same index and radicand. They have a 2, but one's square and one's cube. So we can't combine those. And that 4 is just a constant. It doesn't have a root 2. It doesn't have a cube root 2. So we actually can do nothing to this. So our answer is just the problem. And let's write a little explanation here. These are not like terms, so we cannot simplify. Okay? Here's another one. 4 root 10 plus root 13 minus 9 root 13. First thing we can do is combine our like terms. I see root 13 and root 13. So I'm going to take this coefficient, which we know is a positive 1, and subtract 9. So that is 1 minus 9 gives me negative 8 root 13. Let's look at the 4 root 10 and make sure that it is simplified. Well, 10 we know goes to 2 and 5, and neither of those are perfect squares. So 4 root 10, there's nothing we can do with that. So now our answer, sorry, that does not look good. Now our answer is 4 root 10 minus 8 root 13. Root 10 and root 13 are not like terms, so they could not be combined. Of course, another way you could write your answer is like this. The order of these does not matter. All right, one more. 5 root 3 plus root 48. I want you to try it and then check your answer with me. All right, root 48, that needs to be simplified. So we want to ask ourselves, if you're using the method that I'm using, what is the biggest perfect square that can go into 48? And that is going to be 16. So this is root 16 times root 3. Now if you like to use the factor tree, that's awesome, and we should still get the same answer. All right, I know that square root of 16 is 4, so root 48 actually gives me 4 square root 3. Let's bring down that plus sign and bring down that 5 root 3. Well, now these are like terms. So I take the 5 and the 4. 5 plus 4 is 9. And we have 9 root 3. Let's look at our second property. This is the property of multiplication of radicals. So in words, to multiply radicals, the index must be the same. Then we multiply the coefficients together and the radicands together. And I'm going to call this outside, outside, inside, inside. So here's what this means. If I have a square root of b times c square root d, then what I do is take the outside times the outside, the a times the c, and then I take the inside times the inside, the b times the d. Okay, so that's what we're going to do. Here's our problem. 3 root 5 times 7 root 2. What do we do? Outside, outside, inside, inside. So this equals, well, outside, outside is 3 times 7, and then inside, inside is 5 times 2. So now let's multiply them. 3 times 7 gives me 21 on the outside, and the inside, inside, 5 times 2 is 10. So 21 root 10. Next one, outside, outside, we know this number is a 1, so 2 times 1. Inside, inside, we have 3 times 3. Now I want us to look at this. When we learn the barn method or the factor tree method, we know that under a square root, when we have 2 of the same animals or 2 of the same numbers, we can actually bring out one of those. So if I have the square root of 3 times 3, I can actually bring out a 3 and multiply it by the 2 and the 1. So our answer to this is just 6. Here's another way to look at it. If that was confusing, look at this with me. We know it's 2 times 1, square root, 3 times 3 is 9. Well, what's the square root of 9? The square root of 9 is 3. So now we have 2 times 1 times 3, which is 6. Let's try a couple. First one, we have root 7 times square root 14. I'm going to show you 2 ways to approach this. So the first way, which is the one I will tend to use, of course we use outside, outside, inside, inside. Well, the outside, outside is just 1 times 1, and then inside, inside is 7 times 14. So the first method is actually write them side by side instead of going ahead and multiplying them. The reason we can do this is because then we can break down the 14 and look for our pairs of animals if we're thinking about the barn. So how can I break up 14? Well, I know I have this 7, and I know 14 can be broken into 2 times 7. So now I have the square root of 7 times 2 times 7, and we just look for pairs of numbers. I see a pair of 7s, 2 7s. So what does that mean? That means I can bring out 1 7, and what's left inside the square root is my 2. So that's using the barn method. And our answer is 7 root 2. Second way we can approach this. Some people like to just go ahead and multiply these numbers. So outside, outside is 1. Inside, inside, 7 times 14 is 98. So we have the square root of 98. Well, once you do that, you can go ahead and make your factor tree, or you can write out the greatest perfect square and what it multiplies by. So the biggest perfect square we can take out of 98 is going to be 49, and 49 times 2 gives us 98. Well, the square root of 49 is 7, so we have 7 root 2. So this really depends on how comfortable you are with your perfect squares. I personally like this method because then we have smaller numbers we can break down, but if you like multiplying them and then finding that biggest perfect square, go for it. Here's our next example. 3 root 2 times 5 root 10. What do? Outside, outside, inside, inside. So I'll show you both methods again. For the first one, outside, outside is 3 times 5, and then inside, inside is 2 times 10. Well, we can go ahead and do 3 times 5 is 15. And how can we break up 2? Well, we can't. That's just 2. How can we break up 10? 10 goes to 2 times 5. So now I see a pair of 2's. I can bring out a 2, and I need to multiply it by the outside because that's a new outside number. What is stuck inside is square root 5. So now our answer is 30 root 5. Well, let's look at the other method. Remember method 2. We still do outside, outside. That's 3 times 5. And inside, inside is 2 times 10, which is 20. So I'm going to go ahead and multiply those. And now you can either do your factor tree or you can do the perfect squares. So if I'm looking at perfect squares, I know that 20 is the square root of 4 times the square root of 5. Well, the square root of 4 is 2. So now I'm going to multiply the 2 times 15 to give me 30, and then root 5. 2 more. Number 3, we have negative 2 root 6 squared. Well, what does it mean for something to be squared? It means we have 2 of them. So I have negative 2 root 6 times negative 2 root 6. That's what that means. Again, because we're multiplying these, and on the inside they're just one coefficient with one root, we do outside, outside. So negative 2 times negative 2. Inside, inside, the square root of 6 times 6. Well, 6 times 6, we actually don't have to break those down because that's a pair of numbers. That's a pair of animals in our barn. So we can bring down a 6. We know that negative 2 times negative 2 is positive 4, and we're just going to multiply those. So I brought out a 6, I can multiply them, and 6 times 4 gives me 24. Last problem for multiplication is going to be root 5 times 4 minus root 20. Well, what do we do when there's something outside of the parentheses? We distribute. So I'm going to distribute that root 5 to the 4, square root of 5 times 4. Again, we're going to do outside, outside, inside, inside. And this one's kind of tricky because the 4 does not have a square root. So when we do outside, outside, we do 4 times 1 is 4. And inside, inside, there's no inside on the 4. So we just take the root 5. A common mistake here is people trying to multiply those and give me root 20. But that's not true because the 4 is not under the root. Alright, so now we multiply root 5 times root 20. Outside, outside is just that negative. Inside, inside, we have square root 5 times 20. We need to break down that 20. So we know that 20 can be written as 5 times 4. And I'm just going to bring down the rest of it. Well, I see a pair of numbers. That pair of numbers is 5. So I can bring a 5 to the outside, and then I just brought down that negative sign. And then what's left inside is the square root of 4. I'm going to bring down that 4 root 5. Well, what do we see here? What's the square root of 4? The square root of 4 is 2. So now I have 4 root 5 minus 5 times 2. So 4 root 5 minus 10. But the way we actually write these answers, when we have a constant and then a radical, we always put the constant first. So notice I took the negative with the 10, and then that's plus 4 root 5.